Alright, hello. Welcome to an offline video. Today's video is mildly interesting. We're going to understand how to deploy front ends, as in React projects on AWS. Do we still do this, Harkirat? We have Vercel. Everyone uses Vercel for front ends. Sort of, but as you know, might have seen slash heard that Vercel gets very expensive at scale. So it's not the worst idea in the world to know how to deploy front ends on conventional AWS slash GCP slash conventional cloud providers. Reason being, they're much cheaper at scale. Kirat, I looked at the pricing. There's not a lot of difference. Yes, but at scale, AWS gives you a lot of discounts. In fact, India there are education companies that have almost 99% discount, and I'm sure like a Hotstar or Netflix gets almost 99%, or even Zoom. The ones that have extremely high bandwidth consumption, easy to get like 99% discount on, not storage, but like distribution. Harkiyat, what does distribution mean? Let's discuss all of that in this video. Let's get into it. Let's understand how to deploy front ends. Why does this spelling look wrong? Looks right. How to deploy front ends on AWS. Let's get into it. All right. I mentioned two buzzwords in the last slide, which was distribution and storage. Let's understand what both of these are. Whenever you have a website that wants to distribute content, for example, if this is YouTube, what are they distributing? They are distributing a lot of, let's say, MP4 files, video files. If you created a website like Pinterest, what are you distributing? You're distributing a lot of image files, a lot of JPEG files, a lot of PNG files. Not just this, whenever you open any website, if you go to google.com even, what comes back, if you remember, is files. It's a .javascript file, a .html file, so on and so forth. So in the end, every website that you visit needs to send you back at least some content. It might be HTML, CSS, JavaScript files. It might be images. It might be videos. But all these things, all these files that are not data from the database are what are called content. Call it what's the right? Call it objects. Things that are not simple text that is stored in a database, that are like actual files of at least 500 KB to an MB. You can call them objects on the internet. Okay. Whenever you open a website, you receive back objects. The question is, what is the standard practice to store these objects? What is the standard practice to get these objects on the internet? A lot of people ask this, ki Harkirat, this was our front-end application, this was our back-end application, and this was our database like Postgres or MongoDB. A lot of people asked, Harkirat, how do you store images here? Because I have a use case where I want to store images. But an image is exactly what an object is, and you should never store it in a conventional database. Harkirat, how do I differentiate what should be stored in a database and what shouldn't be stored in a database? Any data you want to search upon, for example, your users in your application, their to-dos in the application. If you are creating a YouTube like website, all the video metadata, the title of the video, the number of views of the video, these should all be stored in a database. What should not be stored in a database? Objects. What do I mean by objects? The final MP4 file that gets streamed to you, let's say on YouTube. YouTube does not stream MP4 videos, but you get the idea. Whatever format they stream, all those files, images, JPEG files, SVG files, so on and so forth, all of these should never be stored in a database. They don't reside in a Mongo or a Postgres. So the question comes, where do you store these objects? And the answer is object stores. There's a specific kind of database, or more specifically, store that is created for these things, which are called object stores. Every cloud provider has them. AWS has the most famous object store called S3, which stands for Simple Storage version 3. That's why it's like S3. Yeah, I think so. Name could be different. Most probably it is. That is what S3 means. Simple Storage says, okay, if you want to store a website, if you want to store an MP4 file, come to me. I'm like Google Drive. Okay, I'll give you a dashboard, upload your files here, let's say an MP4 file, get back a link, and then, you know, whatever, s3.aws.com/a.mp4. Give this to your users. That's where your MP4 file is hosted. You can use it on the website, you can use it somewhere else. We give you back an MP4 URL of whatever you upload here. Think of it as very similar to Google Drive. Okay, you get a GUI, you upload something, you get back a URL, you give it to your friends. With a mild twist. The mild twist being, okay, if you give them this URL directly, it's not the best practice in the world. I repeat, if I go to, you know, googledrive.com or even, you know, S3, let me just open AWS and quickly show you S3. Don't get overwhelmed at all. If I click on S3 here in my AWS console and click on one of my buckets, think of these buckets as, you know, every account has its own set of buckets. I might have 10 different applications, YouTube, Pinterest. I'll keep all the YouTube data in the YouTube bucket, Pinterest data in the Pinterest bucket. In this case, I've kept the images that come on app.100xdevs.com. For example, you know, this image, not exactly these images, but, you know, these images, the machine learning image, I have stored here in Harkirat's CMS. If in the future I have a different application, I'll create another bucket for it. If you open this, as you can see, it has course thumbnails. If I click on it, it shows me the ml.jpg, which is this machine learning photo. And then, you know, folder.jpng, which appears when you open the dashboard, actually log in there, so on and so forth. So this has all of my files. And how do I add a new file? Simple drag and drop for now. There are other ways to do it. But if I really want to add a file really quickly, I'll just copy it from here, drag it over here, click on upload, and then that file gets uploaded over here. Storing a file, very similar to storing in Google Drive. Question is, how do you distribute the file? How do you get the link of the file? And as I said, you can either copy this S3 URL and give it to your friend, but this is bad practice. And even if you try to do that right now, you'll see it says I have disallowed direct access on this link. No one can copy a link from here and, you know, paste it here and get back my file. I've blocked it. I've only distributed my files a certain way. Let's understand what that way is. For that, we need to understand a jargon called CDNs, or Content Delivery Networks. What is the first jargon we understood? What were the two jargons we had to understand? Storage and distribution. For storage, we understood something called object stores. Object stores is where we store data. For distribution, I'm going to introduce another term called CDNs, or Content Delivery Networks. So what happens is, once I've created this file in my object store, this file actually exists somewhere, right? If this is the world map, when I came to this AWS dashboard and uploaded a file, that file reached, let's say, a server of AWS here. It's present in a single location, my a.mp4 file. Now let's say a lot of people start to ask for this file. There's one person here in India, one person here in whatever this continent is, one in Australia, one South America, North America. All of these people are asking for files. All of these requests will go where? It will go to a single location through very long wires in the ocean, a bunch of router hops. The request will reach here, response will come back. But this is a very big file. This is like a 1 GB file sometimes, you know, that slowly gets streamed, or, you know, a 2 MB image. Wouldn't it be nice if you know, a lot of people in India are asking for it, then this request first reaches a server in India, and then from here it gets cached over here, and everyone in India gets this request from here. That is what a content delivery network lets you do. The name itself has, the job is to deliver content. Content delivery network. What does it do? It says, there are many object stores in the world. S3 is one, someone else is a different one. Let that be the source of your truth. But as people ask for your MP3 file or MP4 file, don't distribute it directly from the S3 URL that I just showed you. Don't distribute it directly using this URL. Use my URL, my CDN URL, and tell me what the source is. Matlab, when you create a CDN, you tell the CDN the source. KR, the source is this thing right here. hkirathcms.s3.amazonaws.com. s3.hkirathcms.aws.com. Whenever you create a CDN, you tell it, bro, this is your source. Anytime someone comes to the cdn.hkirath.aws.com, find whatever they want. For example, they might want a.mp4. Find this from here and cache it. I repeat, whenever you go to, let me explain this better. Right now, I'm on this specific place, the Google Drive, where I put a bunch of things. After I have done this, I will go to a different place here. I will go to the CDN place. I'll go to CloudFront, which is the famous CDN. It says CloudFront. The name itself is CloudFront, which means I'll sit in front of the cloud and let you create a CDN. What does that mean? If I open an existing one, you'll see it says this is the distribution URL name. And what does it point to? If you look at origins, it says I point to hkirathcms.s3.aws east1.amazon.com. What does this mean? It means after I created my S3 store, I created a CloudFront distribution and I told CloudFront, okay, bro, your source is what? It is hkirath-cms.s3.com, whatever. And CloudFront gave me back what? It gave me back a URL that looks something like this. The URL says d2sv whatever .cloudfront.net. So d2sv.cloudfront.net. Now, whenever I go to this d2sv.cloudfront.net/a.mp4, this guy knows okay, my source of truth is this/a.mp4, and it'll get the source of file from there, but it'll do something extra. Whenever this is the world map, as I said, the source of truth is here, S3 is here, but CloudFront, the CDN, has multiple servers all around the world. And whenever I from India go to cloud, whatever the URL was, d2sn.cloudfront.net/a.mp4, this is me from India, my request goes to my closest server, which then asks the source of truth, okay, bhai, give me the mp4 file, gets it back over here, and then caches it. So now that mp4 file exists not just here, it also exists in this POP. And then everyone in India that wants that file, they can get it from here. Of course, it is not cached until infinity. It is cached for some certain time, let's say 2 to 4 hours, after which if no one is asking for it, the cache gets cleared. But do we get how content delivery networks make it very easy to deliver content? The thing that is so hard and expensive that if it exists only in one place, it will be very difficult for people all around the world to get it. CDNs create a bunch of what I call server, but what are technically called POPs. They have a bunch of POPs. POP standing for point of presence. And if anyone asks for something through the CloudFront URL, I repeat, if someone goes to this CloudFront URL /a.mp4, is when their request will be routed to the closest. If the person is here, then the route will be routed to the closest POP, which will ask from the source of truth and cache it and give it back. If, however, we give this URL, the s3.amazon.com/a.mp4, then what? Sorry, there you go. This URL, the s3.amazon.com/ the route to your file. In that case, what will happen? The request will directly go to the source of truth and come back, which is basically means it'll take a lot of time, and everyone is hitting the source of truth, and even if someone is here in India and 20 people are asking for it, all of them are going to US. None of the requests are getting cached close to the user, which is why whenever you have object stores, you usually have an associated CDN so that all the requests to the object store are going via the CDN. The object store stores your files in a single location, let's say US East. The CDNs have multiple servers all around the world, multiple POPs all around the world. And whenever someone in here asks for something specific, the request first goes to the POP. If the content already exists here, you get it back. If the content does not exist here, the POP asks the source of truth, gets it back, and then caches it over here so that all future requests to people here can be served via this POP. Hopefully that clears the importance of having CDNs in case of these heavy applications, in case of these applications that are not just serving data. For example, your user information that exists in a database. These are serving actual real world assets. Assets being MP4 files, JPEG files. So you need not just an object store. You also need a CDN. This is used for storage. This is used for distribution. You are charged for both of them. If you put in AWS 2 GB of file, it will charge you something, let's say $0.02 per month. If 100 people visit it, that means 20 GB of bandwidth was consumed. Then you will be charged something else like $0.01 for distribution. Usually what is higher? Can you guess? The distribution cost is higher. This is what you optimize for. If you have a cricket game going on, just a 1 GB file is reaching the object store, let's say in an hour. In a cricket match, what happens? If this is India map, this is where the cricket match is happening. Video gets streamed out of here to a server, which is your source of truth. So this is the stadium. This is the place where you're storing all your data. This will get, let's say, 1 GB data per hour. But this data is going to so many POPs in India that the distribution cost is 1 million GB per hour or something like that. That's the amount of data that's flowing out, which is why this cost is usually much higher than this cost. Harkirat, in what case would this cost be more than this cost? If you have no users. If you have no users, a single user is visiting your website, then of course, storage will be more expensive. But usually whenever you're building a website, you're optimizing for at least 100 people coming to the website. So when you are asking AWS for discounts, you ask them on CloudFront, or you try to find the cheapest CDN. You don't necessarily have to use CloudFront, by the way. You can use a different CDN as well. There are 100 different CDNs available that are compatible with S3. So you can still use S3 as your object store. You can have multiple different CDNs based on, whoever is giving you the better price. All right. That's all for a high level overview of CDNs and object stores. Now let's go through the slides and understand how you can practically start to deploy front ends on AWS. Maybe one more thing I want to cover is a question you might ask. Okay, Harkirat, you said front ends need to be distributed via CDNs. Why not backends? If I have, this is the world map, and this is India, this is Australia, whatever, Asia. If I deploy a backend application and the server where I deployed it, if you remember EC2 from the last class, that server exists here. Why don't we use CDN in front of an EC2 server? Why don't I say, okay, multiple POPs? And then any time a user asks for a data from here, it flows from this POP back to this location right here. Why can't backend data be cached as well? Can you guess already? Take a pause. The answer is pretty simple. I can give you a hint. If 100 people ask for an MP4 file, all of them are requiring the same MP4 file. But when you hit the server for, let's say, on a /me endpoint that gives you back your details, every user gets a different data. User 1 gets email harkirat@gmail.com. User 2 gets whatever email, a different email. What does that tell you? That tells you cannot really cache backend data. You can't really be like, I will have, CDNs all around, and if someone from India asks for something, I will first, check. If someone from India asks for something, I will check this POP. If data doesn't exist, I'll get it from here and cache it here. You can't cache it here. Because if another user asks, they want something else. Their response would be something else. The data is very user specific, which is why CDNs don't make a lot of sense in case of backend applications. What do make sense is something called edge networks, which basically means, okay, you will deploy your backend application here, 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 here. You'll have various places your backend application is deployed. And then whenever a user wants to ask for a backend request or send a backend request, it'll reach the closest edge network. It'll process the request and respond back to the data. There is no caching though. You can have multiple servers that serve your backend request, but you cannot cache data at all, because if you cache data, if user 1 asks for something, they get some data and that data gets cached. User 2 asks for data, they get that cached data, which they should not get. They should get their own data and not a different user's data. That is why caching is a no-no. I mean, you do caching in backend applications, but not like this. But edge networks, or basically, deploying your backend application various places, is a good thing. Harkirat, why don't we do the same in S3? If this is the world map, why there is a single source of truth? Why can't we have multiple source of truth? Why do we even need a CDN? Just have the data in multiple places. The answer is the data here is really expensive. If there's a 1 GB file, you don't want it replicated in 32 POPs or 32 servers. You need it in one ActMax 2 for resiliency. You can't really copy it over to 32 places. It will be very expensive, which is why source of truth is usually one. As people want it, the source of truth copies it over to other caches. As people don't want it, caches keep on getting cleared. All right. With that, I think that's enough context for today. Let's get into creating your own S3 bucket, putting some data there, distributing it to the internet. More specifically, the data that we're putting there is a React website. So understanding how can you deploy front ends on the internet. Let's get right into it. All right. Now let's get into actually creating all of this. I would urge you to go to projects.100xdevs.com, and there is a AWS front-end deployments track, not this one. This is for backend, the front-end deployments track, where we'll understand how you can do all of these steps one by one. Step number 1 is signing up and getting an AWS account and making sure you have S3 and CloudFront access. So just go through the standard process of signing up here. They do require a credit card. I think you can find a dummy one as well. If not, get a real one. Either way, for you to be able to get into the dashboard, you will need a credit card. They also do some PAN verifications. Once you do all of that, you'll be able to reach a screen that looks something like this, where as long as you went through the standard route, you should just have access to S3 and CloudFront. So just open S3, make sure you can see something like this. Just open CloudFront and open something like this, and make sure you're able to see everything here and explore the AWS dashboard. You don't see any red check marks. You will see red check marks if you asked for permissions from a friend on their AWS account. If you are the root user, you should just have access to everything. That's step 1. Only if you've done this should you proceed from here when we actually start to create a React application and deploy it. Step number 2, building your React frontend. Now in the end, we want to deploy a React project onto the internet. There is a big call out here. This approach will not work for frameworks that use server-side rendering like Next.js. I'll explain what that is, but at a high level, for basic applications like normal HTML, CSS, JavaScript applications, and React applications that can be converted down to HTML, CSS, and JavaScript, you can use this approach. For approaches which use some high level, some more extra concepts like server-side rendering, which is something that Next.js provides you, this approach will not work. In that case, you don't have files that you just distribute. You need a server as well, which is why different approach to follow for a Next.js project, for a React project, or if you have a simple HTML, CSS, JS project, then this approach will just work. First step is just building your React project. So I would quickly urge you to start a React project locally, maybe make some edits. If you already have a React project, just open that up in Visual Studio Code, and then we'll go from there. I'm going to quickly initialize a fresh React project. npm create vite at latest. Make sure you select React from the framework, and you can select either of TypeScript or JavaScript. I have selected TypeScript, and now open this in Visual Studio Code. Once you do, open a terminal, run npm install to install all the dependencies. run npm run dev to start the project locally. If I open this now, you will see I have a website running. Let me close this and open it in Brave. I have the React application running locally. This is cool because now if I open Visual Studio Code on the left and I open, see Daisy, sorry, 1 second. And I open the React project on the right. If I open app.tsx here, and if I make a file change, for example, if I change Vite plus React to Vite plus React and save it, it automatically appears here. The command that I ran was npm run dev. It has dev in the name, which means you use this to serve your website in development mode. When you know you are making changes, you want to quickly debug, okay, if I made a change here, how does it appear here? Then you use npm run dev. This is not the way you deploy the application on the internet. You might be tempted to do this. npm run dev is how I've been, deploying applications locally. But in the end, a React application, if you remember from our initial classes, eventually gets turned down into HTML, CSS, and JavaScript. And that is what you distribute over the internet. You don't distribute app.tsx. In fact, here also, what you get back are HTML, CSS, and JavaScript files. If you refresh this page, you will see I got an index.css, an HTML file, a bunch of JavaScript files. You don't get back, JSX files. That is not what React is your browser is supposed to understand. Your browser doesn't understand any of this. Your browser only understands HTML, CSS, and JavaScript files. That is what you distribute over the internet. All right, so the question you might ask is, Harkirat, how do you serve front-end applications or React applications then if npm run dev is only used when you're developing locally, so that if you make a change here, it immediately appears here? How do you actually deploy applications on the internet? And the answer is you first convert it to HTML, CSS, and JavaScript, and then you distribute that HTML, CSS, and JavaScript onto the world. This JSX or TSX is just an easy way for us to write React applications. In the end, they're going to get compiled down to HTML, CSS, and JavaScript. And the way to do that is run npm run build, which basically is build the project. Again, where you can find all of these scripts in package.json. If you go to package.json here, you will see it has a dev script, a build script, a preview script, a lint script. What are the two ones we are using today? Dev to run it locally, build to convert it into HTML, CSS, and JavaScript. If you look at the output from npm run build, it says 4 new files have been created: an index.html file, an svg file, which is probably the svg of this Vite logo, index.css, index.js. It has created 4 files for you. And now these 4 files are enough for your website. You don't need any of this. In fact, if I delete all of these files right now, you don't have to do it. But if I delete all of them and just have dist, this is enough. This is all my website needs. You don't need any of the files that existed outside. Your final bundle has been created. This is what you need to distribute over the internet, just like you would distribute any other any other HTML project. There's nothing special going on or reactified, any special React way you need to distribute this project. Simple index.html file, simple CSS file, JavaScript file, you distribute it whatever way you want. If I click on this JavaScript file, you will see it has a bunch of code. Similarly, CSS, you don't have to understand all of this. Basically, is a bunch of React code that you can now independently distribute. You don't have to worry about all the React logic that was here. Cool. Question is, Harkirat, can you show me this locally? How can this dist folder, it has an index.html file you mentioned. So does that mean if I open this dist folder in my file explorer and double click index.html, I will see my React project? I don't see my React project. Yeah, this might have there's a way for this to work as well. But as you can see, the problem that comes when you go to this index.html file is it's not able to access your index.js file, CSS files, which is why you see a white screen. What you want is a slightly easier way, or a slightly cleaner way to distribute this dist folder. And one of the things that you can do is use this module called serve. So if you run npm install-g serve, which means globally install serve, so that you can run this command in your CLI or in your terminal. And then you run the command serve serve. Maybe go to the dist folder. I repeat, go to the dist folder and then run the command serve. What this will do is it'll start to serve all of your files that exists in the dist folder. So it'll start to serve index.html, file.svg, and all of these files on a port. So if I go to localhost colon 3000 now, you can see I have my website. I can go here, or I can go to /index.html. Both mean the same thing. If you go to slash and nothing exists there, it defaults to /index.html. If I open this, you can see I see my website finally created without any of the React code, purely being served from the dist folder. That is what, like how React is supposed to be distributed. You have these files that you need to serve over the internet. If you want to try it out locally, you can use serve. You can do 10 different things. You don't necessarily have to use this serve. You can create your own express server that is serving these files. In the end, what you have to do is serve these files on a port so that people can, visit them and get back the HTML, CSS, and JavaScript. You cannot just open it directly in the browser. As you saw, the console had a bunch of errors when you did that. Quickly to show what exactly this serve is, if you open serve on npm.js, basically the place where you can read a lot of docs, what does it say? It says serve helps you serve a static file. In the end, what we have created is a static site. What does that mean? It has index.html, CSS, JavaScript. It's not exactly a static file, but in the end, there are a bunch of files that I need to distribute, a bunch of files that I want other people to be able to access. And serve helps you serve those files, which basically means exposes all those files over a port. If this isn't the only thing that serve lets you do. If I go to my root folder, let's say, if I go to my root folder and type serve here, I'm serving my complete file system now. If I give this URL to someone on my network, they can, start to explore all of the files that I have. So I should probably stop this, because then they can, explore my file system completely. If someone in this hotel goes to, my IP, which is could be 192.1.1.1:3000, they can explore all of my files. So I don't want to run serve in this root folder, but you get the idea. It serves all of your files so other people can, access them. Now, if the thing that is being served is index.html, or the first file that's present here is an index.html file, your browser understands that this is an index.html file. Let me render it as a page. Cool. So what have we learned? We have learned a React project in the end spits out a bunch of HTML, CSS, and JavaScript files. And this is probably what I want to send over to S3 so that people all around the world can start to visit my HTML file and see my website deployed over the internet. So the next step is actually taking these files and uploading them to S3. If you go back to the slides, we're done with step number 2, which is building your project. We have tried running it locally. Now let's upload it to S3. There's a quick overview here of CDNs, which I discussed initially as well. Let me take you through it one more time. Okay, you might be tempted to take the EC2 machine approach. What is the EC2 machine approach, Harkirat? Basically what we discussed here on AWS deployment EC2 when we were discussing how to deploy backends. You might be tempted to take this approach for the front-end project as well, but you shouldn't. Why? Because we discussed initially, an EC2 machine is only present in a single region. Everyone will get your HTML, CSS, and JavaScript from there. But since this is a front-end, since everyone is going to get the same HTML and CSS and JavaScript file, why not take a CDN approach? All the files, this diagram looks so wrong. Okay, all the files are present in this, not EC2 machine, this diagram is wrong. All right, someone's getting fired, and this looks like a better slide now. The CDN approach says, all the files are going to be present in an object store. The object store can be anywhere, could be in India, could be in Australia, could be in the US, but there are multiple POPs all around the world, and your front end gets cached on these POPs as people from various parts of the world ask for your data. That way, data gets cached very heavily, which is something you need when you have a lot of files. It doesn't matter too much if it's simple JSON data, but as you get into the realms of JavaScript files, CSS files, HTML files, MP4 files, JPEGs, you want to cache them aggressively, and CDNs are the popular way to do it. So you don't want to take the original EC2 machine approach we discussed in our last week. You want to take this CDN approach. For front ends, MP4 files and images, object stores plus CDNs are a much better approach. You can't use the same for backends since every request returns different response and caching doesn't make any sense over there. User needs user specific response. If you want, this is a very nice video by someone at Hotstar, which shares how they scale during cricket matches. And they also have a similar requirement. The match files are in the end a bunch of video data, right? So it needs to be cached very heavily. They rely on CDNs very heavily. Very nice video to go through if you would like to read through their architecture a little bit more. Cool. Next up, let's get into some coding. Let's start, not exactly coding, dashboarding. Start to upload our files to S3 and distribute them over the internet. So I would urge you to, at this point, go to S3 and create a new bucket. So since we have a new React application, I'm going to create a fresh bucket for it. I'm going to call it React app Kirath 12, which means my week 12 application. And let everything be the way it is by default. You might be tempted to, uncheck this box. Don't. The most standard way to protect your data is to always block all public access and then slowly give CloudFront some minimal access, but you don't want to open this. You want to keep all access to this bucket blocked by default. Okay, so basically just the name here, and that's it. Everything else can be default, and create a bucket. This is where you can start to put your data. So if I open the React app Kirath 12 bucket, I need to put my HTML, CSS, and JavaScript files here. So let me open Visual Studio Code, open my dist folder, or just copy all three of these over here. No, let me do it. This is my final dist folder. I'm going to take the index.html file, file.svg, and assets, and I can just drag and drop them over here. That way, all of these files which have my index.html, JavaScript, CSS files are all uploaded to S3. And now if I go to this specific bucket, you can see it has index.html on the root, file.svg, assets, so on and so forth. If I open this, there is a URL, but as I said, we have blocked all public access. So you can't just access this specific URL. If we do open public access, you will be able to access this, but you don't want that. You don't want data to be distributed via S3. It's very expensive. It's very slow because every request is going directly to S3. You want to distribute this via CloudFront. So after you're done with this, you've created your bucket and you've put your data over there, which is the index.html file, file.svg, and this is when you can actually start to, go to CloudFront and distribute it. Make sure you don't have a folder pasted here. Index.html should be present here at the root level. You should not have a folder called dist which has index.html. All your files should be present here raw. All right. Cool. Creating a bucket was step 4. Uploading the file bundle was step 5. Hopefully that's straightforward. Step 6, try accessing the website. You don't have any access. Step 7, connecting to CloudFront. This is the interesting bit of where you start to, number 1, create a CloudFront distribution, and number 2, give the distribution access to your S3, because right now S3 is blocked from everywhere. No one has access to S3. The way to create a CDN or a CloudFront distribution is go to CloudFront, click on create distribution, and select what is your root, your source of truth. As you can see, it gives me some examples, but you can literally put anything here. You can put google.com, or if you have a different object store somewhere, you can put the link to that over here. If you have, let's say you have a case where you want to cache a backend application, you can put that here. Does not matter. In our case, we're storing our objects in S3, so I can simply select React app kirath.s3.amazon.com. But in the end, CloudFront is a CDN. It lets you cache anything. Doesn't necessarily have to be only objects in S3. Cool. Leave this as optional. This basically means, if you did by mistake, let's say, stored your data in here in a dist folder, then you could have selected ke haan bhai, my origin path is a dist, which basically means find everything inside a dist, but we kept everything in the root folder, so you should be fine. Enter URL, append the original domain for request. Yeah. Name, you can give it anything, leave it as such. Origin access, this is important. Basically means, is your origin open? Is it public? Or is there some access control over there? What did I say? I said this is blocked by default. This bucket we have not open to the internet. No one can access it, which is why our bucket is not public, which is why you can select either one of these origin access policies, which means how do you let CloudFront access your origin? How can CloudFront get some access on S3? There are multiple ways. The one that we are using is origin access control setting, which they recommend, which basically lets you create a new origin access control. कि हाँ भाई, I am going to create a new policy that will define how CloudFront can access this specific S3. You can either select you most probably don't have an origin access policy already. So click on create a new OAC, give it whatever name you want, leave it as such. Select signed requests because it is recommended. It's slightly more secure, and click on create. When you do, I repeat, what are the steps? I went to create S3, create a CloudFront distribution, selected my source. My bucket is not public by default. I added कि भाई I'm going to give you some access over it and going to open up my S3 just to this CloudFront. For that, you need to create a origin access policy. I created a fresh OAC, and then when I did that, you can see it gives me a warning. It says you must update the S3 bucket policy. It says कि भाई I have created a new origin access control. I have created a new way for your origin to be accessed, but you haven't yet put it in the origin. So by the end, you will be given a file. Just put it here in S3 is what this warning says. This makes it much easier to do this. Trust me, like they did not have this warning for the longest time, and you would Google your way away. Okay, how exactly do I give or this CloudFront access to S3? My most popular Google question might be this. Okay, how do I give CloudFront access to S3? And in the end, I would get frustrated and just open up the permissions. I would just go here and then, open up all of these. I would not block access. I would just click on edit here and open the bucket because it would get so frustrating. Since this was a common problem, they now give you a very nice warning. Okay, I'm going to give you by the end of this something. Just put that something in S3 and you're good to go. If you otherwise it would have been like a pain to figure out what exactly this policy is and how do I paste this in S3. Cool. So to recap, added the origin, created an OAC, and it told me I'll give you a file in the end. Put it in S3. I'm going to wait for while I create it, and then I'll get the file and put it in S3. Everything else can be almost default. We have to change a few things. Let me show you what. You can enable security protections here for your website. Simple website does not matter, but it gives you some extra protections in case you are under attack or your CloudFront is under attack. So feel free to select enable security protections over here. We'll eventually get to how you can point your own domain name to it, but for that you need this section. Feel free to ignore it for now. Eventually we can add it. And then this one's important. Default root object. What are we creating? We are creating a website. You look at it. Where does our code reside? What is the root file? Index.html. But when you give your friend a URL, do you want to give them a URL like this? Do you want to give them something.amazon.com? Or do you want to give them amazon.com/index.html? You want to give them a URL like this. Like you never go to google.com/index.html. You go to google.com, which is why in CloudFront you can say my default root object is index.html, which means if someone goes to my CloudFront URL, by default, if they don't give anything at the end, the file that should be picked should be index.html. So I can easily give out URLs rather than giving out URLs like this. Does that make sense? So this is one extra thing you have to do in case you're creating, a CloudFront distribution for a website. If you were doing it for an MP4 file, then it's fine. When you're giving an MP4 file to your friend, you can totally be like, a.mp4. Or if, you go to app.100xdevs.com. I'm not logged in here. Let me try here. If you look at this file path, it says the CloudFront URL /course thumbnail /ml.jpg. So here it is fine. You can have whatever suffix at the end. But when you're distributing a file, in that case, you don't want a suffix. In that case, you simply want, the default object is index.html. Everything else can be standard. Click on create distribution. And now it gives you a policy. It says S3 bucket policy needs to be updated. Complete the distribution configuration by allowing read access to CloudFront origin in your policy. So you have to go to S3's permission page, specifically the permission page either here, you can directly go, or it links you to it. After you reach this permissions page, there is a bucket policy where you share ki haan bhai, public access it says is by default blocked. If you want to add some access, you can, but by default, all access is blocked, which is why if you click on edit, it thankfully gives you a very nice policy, which we can try to read through, but usually you use some sort of a generator like this to, generate this policy. What does it say? It says, allow CloudFront service principal, this resource, which is the S3 bucket with the bucket name React App Kirath 12, which is my bucket right here, should be allowed access from this CloudFront URL. So this is the ID of my CloudFront that I just created. As you can see, it says E3A2F. If I go back to CloudFront, E3AUF. So what policy did it generate? The policy that it has generated says, okay, this S3 path, anything inside this bucket /* should be accessible to this CloudFront distribution. That is the policy that we have now generated, and this is the only access we have provisioned on S3. So now S3 is still blocked all across, but we added one permission कि हाँ, this specific CloudFront distribution should be allowed to access S3. Nothing else should be allowed, but this one thing should. That's how you can gate access very well to CloudFront, so that only your CloudFront distribution, only if someone is coming to this website, can they reach S3. There is no other way for them to, directly access S3. Cool. So that's the extra step, which, as I said, now they give you this very nice, warning all across. But before this, you would have to figure this out by Googling and, reach some sort of a policy, edit out this ARN, figure out what the ID is, put it here, and then, finally create the policy. Eventually, you would just get frustrated and completely open the bucket. But yeah, you get the idea. Now they've made it slightly easier, and that's it. That's all you have to do. Now you just have to wait for deploying to change to completed, and then you have a basic website up on the internet. There is still a problem. The problem is you don't want to give your friend this URL. You want to give your friend a URL that looks like app.100xdevs.com or frontend.yourdomain.com. So how do you do that? We'll see the next section. But let's wait for this to deploy, and then we'll try to visit the website. All right. Now, as you can see, it does not say deploying. It says it was last modified on this date. Basically, it means my website is deployed. If I copy this and paste it here, you will see I have my React application. If I open inspect, refresh one more time, go to the network tab, you will see by default, I get back the index.html file contents. I get back the contents of the HTML file and not, even though nothing is present here, because I select the root object as the index.html file. The index.html file then asks for /assets/index.js, which, then hits CloudFront URL /assets/index.js, which is why I get the JS file here, I get the CSS file here, so on and so forth. I have my complete front end deployed on CloudFront, which is one of the best distribution strategies for a static file like this, because CloudFront has a lot of POPs, very cheap, owned by AWS, yada yada. This one's simple. This was pretty not too difficult. The difficult bit is connecting it to your own domain. So now let's understand, if you own 100xdevs.com, how can you point either 100xdevs.com to this website or some other root subdomain like week12.100xdevs.com to this specific website? For that, you can do this while you were creating the distribution as well, or once you've created it, you can click on edit over here in the second section. So if this is your CloudFront distribution, you can see it says alternate domain names here, which is exactly what we want. We want to give it an alternate domain name. So if I click on edit here, it says add an alternate domain name here. I'm going to add week12fe.100xdevs.com. Again, to call out, I own 100xdevs.com, which is why I can put it here. You will not be able to put this here if you don't actually own a domain name. So if you want to try this out, you will first have to buy a domain name. You can find a cheap one on namecheap.com. Custom SSL certificate. This is important if you want your final website to be deployed on HTTPS, which you should. Any front end or backend should always be deployed on HTTPS and not on HTTP. But Harkirat, the CloudFront URL is already on HTTPS. Why can't, if I just do this, why won't this just work? Why do I need to create a new certificate HTTPS? And the answer is Amazon cannot create a certificate for any random domain. The certificate can only be created and deployed if you actually own that certificate. So you have to first show Amazon you have ownership of this URL. Only then will Amazon create a certificate for you, and you can put it on your front end website. They make it very easy. You can create a certificate yourself. You can buy a certificate on GoDaddy.com, or you can ask Amazon to create one. It's very cheap, if not free, to create an SSL certificate on AWS. So if you want your website hosted on HTTPS, which you should first create a custom SSL certificate. So for that, click on request certificate, and it will take you to another service of AWS called AWS Certificate Manager. So just how S3 is a service, CloudFront is a service, AWS Certificate Manager is also a service. And here you can request for a certificate. What is a certificate? The thing that you need for your application to be hosted on HTTPS. If I go to any URL on Chrome and expand this, how can I see the certificate? There you go. Connection is secure. Certificate is valid. Whenever you go to an HTTPS website, it says certificate is valid. You can actually explore the public key of the certificate, and that's how every website that's deployed on the internet needs a certificate, which is what we are creating for our website. CloudFront has its own certificate. We need to create one for our website, which is why we are going to the AWS Certificate Manager, which lets you create these certificates. So click on next. Domain name. What was our domain name? It was week12fe.100xdevs.com. So this is the domain name that I need a certificate for. Select DNS validation. Here it basically means how will you tell AWS, okay, you own this certificate? And you can do email validation, but this one's just easy. Select any type of encryption algorithm that you want to use. Feel free to ignore. Default one is fine. It's how you want to, the algorithm that you want to use to create your certificate. And in our case, RSA248 is probably the simplest one. And click on request. And now, once you do that, if you refresh, you will see it says pending validation. So you've asked AWS to create a certificate, but it hasn't been able to yet. Why? Because how does it know you own this domain name? I could have written facebook.com over here. You first have to verify that you own this certificate or this specific domain name. And how do you do that? It says, okay, please go to wherever you have bought your domain. I have bought it on Google Domains. So if I go to Google Domains and look at all the domains that I have bought, domains.google.com/registrar, here you will see I have a bunch of domain names. 100xdevs is one of them. So if I click on 100xdevs and click on DNS, which stands for Domain Name Service, I can actually add records here. What do I mean by records? Okay, bhai, where does app.100xdevs.com point? Where does backend1.100xdevs.com point? All these records you can add here. Even if you bought it on Squarespace, even if you bought it on GoDaddy, you will find a DNS section here in that specific provider. Go there and click on Manage Custom Records. And here, add a new record that Amazon wants you to. Amazon tells you, okay, if you want to verify that you own this, please on this domain name, which is, underscore AE whatever .week12fe.100xdevs.com. So just copy the first part here and paste it here. So underscore AE1SE, whatever they wanted me to point, whatever subdomain they wanted me to point to what value. They say the value that you have to point it to is this. So I'm going to copy this and paste it here. What was the type? CNAME. So they say create a CNAME record for this subdomain to point to this value. This is the same thing that you have to do to show how you do actually own this domain name. After you click on save here, AWS will hit this URL. It will hit underscore A. It will hit underscore AE1.100xdevs.com, this specific URL, and try to see, did you put it there? That's how they will verify that Harkeerat was able to put it there. So Harkeerat does own at least week1.2fe.100xdevs.com because he was able to put an entry on a subdomain of it. If I click on save here and then wait for some time, AWS will be able to figure out that Harkeerat does own this domain name because Harkeerat just put this in their domain name provider, and since Harkeerat is the only one who has access, or an admin of week12fe.100xdevs.com is the only one who has access to put it, and since he put the right value here, that means Harkeerat does own this specific URL, and then it'll just generate a certificate for me. It won't let you generate a certificate unless you can verify that you actually own that website. Cool. Now you just have to wait for some time until this pending validation changes to verified. Let's refresh. still pending validation. So let's wait for some time. All right. After waiting for some time, it says status issued, which basically means they have issued my certificate. If I go back to CloudFront here and open my certificates, refresh, it says I have a week 12 fe.100xdevs.com certificate created for me. So I can just attach this certificate because that is what I want this specific website to point to. That's it. If you click on save changes now, there is one last thing you have to do. Can you guess? We've done this. We've told CloudFront, okay, if any request comes to you from week 12 fe.100xdevs.com, you should be able to handle it and serve the URL, serve the contents of S3. So now someone should be able to realistically not just goes right now. If I go here, it doesn't show me anything, but the CloudFront URL works. If I go to the CloudFront URL, I see the HTML. I told this guy, okay, bhai, week 12 fe.100xdevs.com you might receive requests from it. So please serve them correctly and serve the S3 contents there, but it's not working right now. Can you guess why? What is the one thing I've missed? I have not yet pointed week 12 fe.100xdevs.com to this CloudFront URL. I did not go to my Google domains. I did the verification bit. I did say ki this thing points here so that AWS was able to verify and generate my certificate. I did not yet point week 12 fe.100xdevs.com, which is, if I write just week 12 fe here, that's what it means, to this URL. I need to create a CNAME record. Okay, week 12 fe.100xdevs.com should point to this CloudFront URL without the HTTPS and save it. That's the last thing I had to do. Now, if I go to week 12 fe.100xdevs.com in like a minute or two, because it takes some time for DNS to propagate, or by which I mean for these records to get propagated all around the world. So I'm going to wait for like a minute and then try to hit week 12 fe.100xdevs.com, and that should hopefully now show me the same contents as this file right here. I was able to deploy a website on CloudFront and attach my URL to it. And that's good because that's what you want to share with your friends. You don't do this a lot of times. If you remember, I showed you app.100xdevs.com. The ml.jpg file was just being served from the CloudFront URL. It's because, I should probably change this to assets.100xdevs.com, but doesn't really matter. It's a hidden URL. But when you're serving a website, that website URL isn't hidden, which is why, you probably don't want to give out CloudFront URLs and attach a domain name. If I go here, DNS isn't yet propagated, which is why it says this. Let's wait for some time and then we'll see if this actually works. All right, the DNS has propagated. And now if I go to week 12 fe.100xdevs.com on HTTPS, I do see a website deployed. So that's how you can convert your CloudFront URL to point your own domain names to it, which is what you want in the end. Now you have an HTTPS front end on your own domain deployed on CloudFront backed by S3, which is a very nice production way to deploy front-end applications, specifically React applications or simple HTML, CSS, and JavaScript applications. Next up, there's one more thing that's left. Can you guess it already? Let me show you what it is. But basically, can you guess if there's a problem here? This does work, but in the end, you have very dynamic website, and by dynamic I mean it has a bunch of routes. You might have a dashboard route, and what happens when I go to dashboard? It cannot find a dashboard file in S3, so it doesn't know where to go. Ideally, there is client-side routing here, and S3 or CloudFront should always return index.html. I repeat, even if I go to whatever route, doesn't matter. CloudFront should return index.html so that React reaches here and then it is able to figure out, acha, the route is /dashboard. So I have to render the dashboard page. In the end, it doesn't matter what route you hit, CloudFront should get back index.html, and then the JavaScript file that will come, the React project that will come, will figure out ki, acha, the route is this specific thing. So this is what I want to render. So what do we want? Last thing we want, if you go back to the slides, I've mentioned this, to add an error page. You will notice a problem that whenever you try to access a route on your page that isn't the index route, you will reach an error page, something like this. But you don't want that. This is because CloudFront is looking for this in S3, which does not exist. To make sure that all requests reach index.html, add an error page that points to index.html. What you can do is, if I open CloudFront or AWS, if I open CloudFront here, I can open that specific distribution that I had just created. And over here, add an error page. Totally forgot. My brain farted for a second. Add an error page. And what does an error page mean? Basically means, if a user reaches a page that looks something like this, rather than showing this dumb error, what should you show them? That's what the original need for something like this was. Whenever the user reaches a page that doesn't exist, what should be the default error page that they see? And in our case, what do we want that error page to be? We want that error page points to, can you guess? If the request reaches a 404, what happens when you go to ASD page? If I click on inspect, select network, what status code do I get back? I get back a 403, which might mean if I select 403 over here and say customize error response, whenever the user reaches a 403, return them back index.html with a 200 status code. Tell them you are good. Here is an index.html file. Do not show them 403, even though when you visit this website, the status that you get back for all of these files is what? 403. It says forbidden. You don't have any file here. You don't have access to this file. That's what 403 status code means. And what are we saying here? We are saying anytime a 403 status code comes, don't return this to user. Give them a special error page, which is nothing but the index.html file with a 200 status code. Tell them you are good. Here is the index.html file. And then index.html file will call for the JavaScript file eventually, which will figure out the path is /ASD. So this is what I need to render based on whatever you might have there, /index.html, based on whatever client side routing you have. If you're using React Router DOM, if on /ASD you render a certain page, that is what will appear here now. So if I now go, one extra thing you have to do is create an invalidation. What happens is CloudFront, what is the primary purpose? Caching. So a lot of this data is cached. The response to /ASD is cached right now. And to make sure you are able to clear the cache, you can create what's called an invalidation, which means invalidate the cache. Doesn't matter what POP has what, invalidate all of it, remove all the cache from everywhere, so that when the user visits this, the cached value doesn't get returned, a real value comes, right? If I go to another URL, ASDA, then it's fine. But ASD was cached, which is why I had to create an invalidation. But either way, now if it does not matter what route I go to, every time I get back the same index.html, because I added an error page. If a 403 comes, don't send a 403 to the user. Send them index.html, which, as you can see, renders our page. Cool. That was the last slide. This was all that you had to do to create. Where did our slides go? Okay. Yeah, all that you had to do to create a front end that just works. The only other things you might want to add after this are, number one, link this to your GitHub so that anytime you push your front end code to GitHub, it automatically deploys to S3. We'll do that in 1-200. It's done using something called a CI/CD pipeline. What else can you do? The other thing that might be good to explore is how can you do the same for a simple index.html project, or simple project that does not have React in it, and then connect it via GitHub. If you want to take an assignment home, try to create a CI/CD pipeline that automatically connects to your AWS and automatically deploys your code from GitHub over to S3. That's an interesting project to build, which we will build in 1-200. But if you want to get ahead, I would urge you to build it. If not that, at least try to go through all these steps. Maybe buy a domain name and try to deploy your application there. Cool. With that, let's end it. I'll see you guys in the next one. Bye bye.